Hello everyone. In this session, I'll be introducing you trigonometry, which is related to triangles. So I actually call it triangle trigonometry only. Now there are books or authors, those who use words like solutions of triangle, etc. But that solution of triangle and triangle trigonometry, it is one and the same. So don't get perturbed because of the names. It's mainly trigonometry. Whenever it is used in applications related to triangles, I call it triangle trigonometry. Now, to start with the topic, there are certain formulae which are required, and at the most, what other thing you need is your geometry, what you have learnt in your previous classes. So this session, mostly, I will be taking only the formulae required. So basic terminology you should know when you are learning triangle trigonometry. Now, if I take a triangle, say ABC, which I have tried to draw here, like triangle ABC, and related to this triangle ABC, various terms I will be introducing to you. Now, what I have done here is side AB I have extended in both the sides. Similarly, side BC I have extended on both the sides. Side AC also I have done. So perhaps immediately you may not be able to see triangle ABC, but if you look at the names, you will realize that where is that triangle ABC. I have drawn there in all 5 circles. 2 are dotted ones and 3 are the bold ones. Now the dotted ones, if you see, there is innermost, that is the red color dotted circle. That circle is called in circle of triangle ABC. The dotted circle which is on the outer side, that is called circumcircle of triangle ABC. And the other 3 circles where inside radii I have mentioned as RA, RB, RC, those circles are called X circles. How are they obtained? Like if I extend AB and I extend AC, then I have drawn a circle which touches side BC and those extended AB and AC. So that circle will have radius which would be named as RA, means vertex A, from there AB and AC were extended. So in my terminology, or universally accepted terminology I should say, is that we write it as RA. That radius we write it as RA. So when I extend BC and BA, and then when I draw the outer circle, X circle, its radius would be named as RB. And similarly, now you know what must be RC. Now at least what figure I have drawn, I guess is clear to you now. Now let us write actually the terms, names, what we use. We call side BC as small a. I mean, this is standard notation. Then side AC, that we write as small b, and side AB we name as small c. I have not written all that in the figure because it would have been otherwise too clumsy. Now, what other names we use? In radius of the circle, in circle of triangle ABC. In radius means radius of in circle of triangle ABC. That is denoted as small r. And capital R is used for circum-radius. Circum-radius means radius of circumcircle of triangle ABC, the outer dotted circle. Then we have, I think, notation for area of triangle also, which we use as the actual triangle notation, which is, I think, not new to you. Then we have used, as I have already mentioned, RA, RB, RC as X radii. Then we have notation as HA also. HA notation we use for altitude drawn from vertex A to BC. HB would be the altitude drawn from vertex B to side AC. And HC would be the altitude drawn from vertex C to side AB. Now, these HA, HB, HC, again, I have not shown in the picture. You can actually draw yourself and remember these names. What we write for HA, what we write for HB, etc. And also, this is the last one, small s, which is semi-perimeter of triangle. This is not a surely new notation to you. Maybe in your 7th or 8th standard, you have already used them. So these are the notations what we will be using throughout in our sessions of triangle trigonometry. Now, we have certain more formulae now. With this names terminology, we will be writing first as the sine rule. it is A upon sine A equal to B upon sine B equal to C upon sine C. And this is equal to obviously a constant. When all three are equal, they are equal to some number. And that number, at times it is written as K. And that K actually turns out to be twice of circum-radius of triangle ABC. So if you wish, you can also write in addition here itself that A upon sine A equal to B upon sine B equal to C upon sine C equal to 2R. Then we have a certain thing which is called cosine rule. We have defined their cos A, cos B, cos C in terms of side lengths. Now cos A is B square plus C square minus A square upon 2BC. Actually, I could have written similarly cos B and cos C you can write. But I have deliberately mentioned there because whenever you see, you'd remember it better. This is what I have always believed in. So realize this, that how are we writing cos A? If you know how to write cos A, you can write cos B and cos C on your own also. So frankly, even if I have written there three formulae, you need not remember all three. You remember cos A, and from there you will be able to write cos B and cos C on the spot also whenever required. Now cos A, how I have written? Minus A square tells you that if you are taking angle capital A, then quantity which needs to be subtracted in the numerator on the right hand side is A square. And obviously then sum of the squares of other two sides. So B square plus C square minus A square upon 2BC. If you remember this style of remembering, how to remember it, then you will be able to write cos B and cos C exactly on the similar lines. Because if you are writing cos B, then minus B square I will have to write. Then I add C square and A square. And then I divide by 2AC. And similarly, you can remember now cos C also. Now next is projection rule, which I'm sure, those who have been studying perhaps vectors, they have used cosine rule and projection rule there. Now projection rule, I have directly given you formulae, all three. Mind you, please, nowhere derivation is required. So let us not get into the derivation part. I generally take in my sessions derivation only when it improves your skill. Otherwise, you better take that as a formula itself. Though I do not believe much in formula application, but I have felt that in triangle trigonometry, at times, if no other method is working, you better apply formula if that strikes you in time. Now, A equal to B cos C plus C cos B. If I remember this one, A equal to B cos C plus C cos B, then I will be able to write formula for small b and small c. I hope you are understanding what I am saying. B cos C, when I say B is small b, means I am talking about the side length. And when I say C cos B, small c stands for side length. I hope you followed that. Now, there are more sets where we have sine A by 2, sine B by 2, sine C by 2. And also we will be having for cos A by 2, cos B by 2, cos C by 2. Let us first concentrate on sine A by 2. Now, sine A by 2 is written as square root of S minus B, S minus C upon BC. If you remember sine A by 2, you will be able to write sine B by 2 and sine C by 2 on your own without even actually remembering. Let us not by heart that particular formula for sine B by 2 and sine C by 2. You can remember only sine A by 2. Now, how I have written sine A by 2, you will realize there is no small a written there. So, it is just combination of B and C basically. S minus B, S minus C upon BC. If you remember this, then sine B by 2 tells you that there will not be B present in it. So, S minus A, S minus C upon AC. And then square root. Similarly, you will be able to write sine C by 2. Now, when I go for cos A by 2, cos B by 2 and cos C by 2, you will realize in numerator, I have S into S minus A in formula of cos A by 2. In formula of cos B by 2, we have S into S minus B. That means if you are taking capital A, then we will be writing small a on the right hand side. If you are taking capital B, then we are writing small b on the right hand side. If you remember such small tricks, it would be easier for you to remember formula. So cos A by 2 is square root of S minus A upon BC. Remember cos A by 2 and then cos B by 2, cos C by 2 will come on its own, right? Now I move to next. And the next one is that I try to write formula for area of triangle, which I have written as delta, or actually the notation name is delta, which looks like triangle. And this formula I am sure in your childhood you have used. Square root of S minus A, S minus B, S minus C. This is known as Heron's formula. Now, this area of triangle can be written in many other ways, like half AC sine B, or it can be half BC sine A, or it can be half AB sine C. I hope everybody is following what I am writing there. when I say AC sine B, if you draw the picture, you will realize small c stands for AB, small a stands for BC. So, including angle between BC and BA is B. So, when you see area of the triangle written as half AC sine B, you are taking half product of two sides into sine of the angle included between them. If you remember it like this, then remaining two you can write on your own. Now, there is one more formula which is in terms of in radius and semi-perimeter. Now, the delta means area of the triangle is equal to product of in radius and semi-perimeter. I mean, these are 5 formulae. Now, which formula is to be used, that you will get to know seeing the question, seeing the information given in the problem, which formula is to be used. Now, there are formulae which are for in radius also, like small r is delta upon s, which comes from the upper formula itself. And there is one more which is nicely written as 4 capital R into product sine a by 2. I hope you understand that capital pi written there. Capital pi notation stands for product. When I say product sine a by 2, it means sine a by 2 into sine b by 2 into sine c by 2. So there are actually 3 terms which we write under one notation, product sine a by 2. So 4r times product sine a by 2 stands for n radius small r. Now, when we will go for x radii, there would be similar more formulae for that also. Now, x radii Ra is delta upon s minus a. Now, when you see in radius delta upon s as small r, now Ra as delta upon s minus a, there is some kind of uniformity which you can remember. Now, when I say Ra as delta upon s minus a, now I'm sure you know how to write Rb and Rc. Will that not be Rb as delta upon s minus b, and Rc will be delta upon s minus c? That was expected. Now, we also have, like how we have for in radius 4r times product sine a by 2 formula, same way we have for Ra, means x radius Ra as 4r, then sine a by 2, and then product of two cos terms, that is cos b by 2 and cos c by 2. Means only one term of sine will appear. So when you are writing Ra, we write sine a by 2. Then for Rb, what you will write? Sine b by 2. For Rc, you will write sine c by 2, and remaining cos terms you will have to write. So Rb becomes 4r into cos a by 2, sine b by 2, cos c by 2. Sine b by 2 has to occur there. Now Rc similarly sine c by 2 has to occur. So 4r cos a by 2, cos b by 2 into sine c by 2. Now, these are formulae which are straight away given. Now, there could be something more also. Again, I will not be getting into derivation part, but I can give you a list of formulae which you can keep in your collection, and as and when required, you should be able to use them. Sigma tan A equal to product tan A. This is extremely important result from triangle trigonometry point of view. Now, sigma tan A, notation sigma tan A stands for what? Tan A plus tan B plus tan C. Product tan A stands for tan A, tan B, tan C. Now, from here only, I have derived the next one. That is sigma cot A, cot B equal to 1. Sigma cot A, cot B means cot A, cot B plus cot B, cot C plus cot C, cot A. Instead of writing that big expression, I have used sigma notation. Now, sigma cos A equal to 1 plus small r upon capital R. Now, again, I am not getting into proof part. If you are interested, you just take paper, pencil and try to derive it. And there is one important theorem which is actually of geometry, but if you know that and if you try to use in triangle trigonometry, no one is going to see you which method you have used. But very, very important theorem, and that is Ptolemy's theorem, which says for any quadrilateral ABCD, product of AC and BD means product of the diagonals is always less or equal to sum of the products of the opposite sides. AB and CD are opposite sides. AD and BC are opposite sides. So you take product of AB and CD, take product of AD and BC and add them. Now this expression is always greater or equal to product of the diagonals. Now the moment I am writing less or equal to, you are a mathematics student. Are you not expected to know when does equality occur? So equality occurs only when ABCD is a cyclic quadrilateral. I mean, these are the results which may be required for your further triangle trigonometry sessions. Please revise them and meet me in the next session. Till then, stay tuned. Thank you.